Hello, future engineers, subscribers, viewers, and students. Here is another video in plane and solid analytic geometry 2, part 2, devoted to problem solving. So problem 1, determine the species of the conic 16x squared minus 24xy plus 9y squared minus 30x minus 40y equals 0. So let us evaluate the discriminant b squared minus 4ac. If the discriminant is exactly equal to 0, it is a parabola. If it is less than 0 or negative, it is an ellipse. And if the discriminant is greater than 0, it is a hyperbola. So in this case, let's evaluate negative 24 squared minus 4 times 16 times 9. So quantity negative 24 squared minus 4 times 16 times 9, it is equal to exactly 0. Therefore, this conic is a parabola. Problem 2, which conic represents xy equals 9? Coefficient of xy is 1, and that is b. b squared minus 4ac is equal to 1, and it is greater than 0. Therefore, this is a hyperbola. Problem 3, what is the eccentricity of the conic 8x squared 12 minus 12xy plus 17y squared minus 80 equals 0. So b is 12, a is 8, c is 17. So 12 negative 12 squared minus 4 times 8 times 17. It is equal to negative 400. So it is an ellipse, and an ellipse has an eccentricity which is less than 1. So the eccentricity is less than 1. Problem 4, how many degrees is the axis of the conic 5x squared plus 12xy equals 4 rotated from the x-axis? So the formula tangent to theta equals p over a minus c, where b is 12, a is 5, c is 0. So tangent to theta is 12 over quantity 5 minus 0. Inverse tangent divided by 2, it is 33.69 degrees. Problem 5, find the equation of the circle with center at negative 4, negative 5 and tangent to the line 2x plus 7y minus 10 equals 0. So remember that distance from a point to a line, the point is the center, and this is the line, the tangent line is the radius of the circle. And since we are looking for radius, that's positive, so let's just use absolute value of ax1 plus by1 plus c over square root of a squared plus b squared. So ax1, 2 times x1, 2 times negative 4, plus 7 times negative 5, minus 10 all over square root of 2 squared plus 7 squared. It is equal to square root of 53. Then this equation of the circle is x minus negative 4 squared plus x minus 8 squared plus y minus k squared equals radius squared. So x minus negative 4 squared plus y minus negative 5 squared equals square root of 53 squared. This is x squared plus 8x plus 16 plus y squared plus 10y plus 25 equals 53. Simplifying, equation of the circle is x squared plus y squared plus 8x plus 10y minus 12 equals 0. Problem 6. Reduce the equation 3x squared plus 3y squared minus 2x plus y minus 5 into the standard form and find the center and radius of the circle. Partially, this is a circle because the coefficient of the second degree terms a and c are equal to 3. Then we transform this equation into the standard form by completing the squares in x and in y. So we have 3 quantity x squared minus 2/3 x plus 1 over 9 So this is plus 1 over 9. 1/2 of negative 2/3 is negative 1/3. Negative 1/3 square is 1 over 9. Then we have plus quantity 3 times y square plus y over 3. 1/2 of y over 3 is 1/6. And 1/6 square is 1 over 36. So we have 3 times quantity y square plus y over 3 plus 1 over 36 equals 5 plus 3 times 1 over 9, or 3 plus 1/3. 3 times 1 over 9 is 1/3 plus 3 times 1 over 36 is 1 over 12. So equals 5 plus 1/3 plus 1 over 12. Simplifying the right side and writing this in factored form, we have 3 times quantity x minus 1/3 square plus 3 quantity y plus 1/6 square equals, the right side is 65 over 12. Dividing everything by 3, we have x minus 1/3 square plus y plus 1/6 square equals 65 over 36. The right side is r squared, therefore the radius is square root of 65 over 6. The center is at 1/3, comma, negative 1 over 6. So we write it in this manner. So the center is at 1/3, comma, negative 1 over 6. The radius is square root of 65 over 6. So that's it for this problem 6. Problem 7. A circle has its center on the line 3x minus 2y minus 22 equals 0 and tangent to the y-axis at 0, 1. Find its equation. So that we can analyze it well, we have to sketch the graph first. Let's have the coordinate axis first. Then this is the line 3x minus 2y minus 22 equals 0, where the center of the circle is lying, and the circle is tangent to the y-axis at 0, 1. So therefore that's the radius. So that's 0, 1. This is supposedly, this center is at h, k, where k is 1, same as this ordinate 1, and x coordinate h is also the radius of the circle. So that is h, 1. That's r equals h, and this is the circle. So we substitute into this equation x is h and y is 1 to solve for h, which is also the radius of the circle. So 3 times h minus 2 times 1 minus 22 equals 0. So 3h equals 24, so h is 8, and it is also the radius. Therefore, the equation of the circle is x minus h, x minus 8 square plus y minus 1 quantity square equals radius 8 square. So x square minus 16x plus 64 plus y square minus 2y plus 1 equals 64. Cancel out 64, and simplifying, equation of the circle is x square plus y square minus 16x minus 2y plus 1 equals 0. So x square plus y square minus 16x minus 2y plus 1 equals 0. Problem 8. This problem came out in the CE licensure exam in November 2012. A circle has its center at negative 4, 3 on the xy plane and passes through the point 2, 5. Find the equation of the circle. So the circle has the equation x minus h square plus y minus k square equals radius square, and the radius square is the distance of the square of the distance between these 2 points. So x minus negative 4 square plus y minus 3 square is equal to 2 minus negative 4, or 2 plus 4 squared plus quantity 5 minus 3 squared. So this is x squared plus 8x plus 16 plus y squared minus 6y plus 9 equals 6 squared 36 plus 2 squared 4. 36 plus 4 is 40. Simplifying, equation of the circle is x squared plus y squared plus 8x minus 6y minus 15 equals 0. 15 minus 15 is 16 plus 9, 25 minus 40, so negative 15. Problem 9. Find the center, radius, and the equation of the circle which passes through the points 1, 2, 5, 4, and 10, 5. So the expected and reduced general form of equation of a circle is x squared plus y squared plus small d times x plus small e times y plus f equals 0. So we substitute the first point on the circle, which is 1, 2. So 1 squared plus 2 squared plus d times 1 plus e times 2 plus f equals 0. Simplifying, we have d plus 2e plus f equals negative 5. Call that equation 1. Then we substitute 5, 4 into this expected general form of equation of a circle. So we have 5 squared plus 4 squared plus d times 5 plus e times 4 plus f equals 0. Simplifying, 5d plus 4e plus f equals negative 41. Call that equation 2. Then we substitute 10, 5 into this reduced general form. So 10 squared plus 5 squared plus d times 10 plus e times 5 plus f equals 0. So 10d plus 5e plus f equals negative 125. We then solve equations 1, 2, and 3 simultaneously. We obtain d equals negative 22, e is 26, and f is negative 35. So the equation of the circle, substitute into this reduced general form, is x squared plus y squared minus 22x plus 26y plus f plus negative 35 equals 0. So this is the equation of the circle. The center is negative 1/2 of negative 22, so positive 11, comma, negative 1/2 of 26, negative 13. So center is at 11, comma, negative 13. And the radius 2r is square root of negative 22 square plus 26 square minus 4 times negative 35. Again, 2r is square root of quantity negative 22 square plus 26 square minus 4 times constant, 4 times negative 35. And r can now be computed. It is equal to 5 square root of 13 units. Problem 10. Does the point negative 3, negative 4 lie inside, outside, or on the circle x squared plus y squared minus 4x minus 6y minus 12 equals 0? What is the nearest and farthest distance from the point to the circle? What is the length of the tangent line from the point to the circle? What is the length of the chord 3 units from the center of the circle? The point lies on the circle if the distance between the point and the center is equal to the radius of the circle. The center is at negative 1/2 of negative 4, so 2. Negative 1/2 of negative 6 is 3, 2, 3. And the diameter is square root of 4 square, 16, plus negative 6 square, 52, minus 4 times negative 12, so plus 48, 100. Square root of 110, 10 divided by 2, 5. The radius is 5, and the center is at 2, 3. So plotting first so that we can analyze the situation. So this is the circle x squared plus y square minus 4x minus 6y minus 12 equals 0. The center is at 2, 3. And the point negative 3, 4 would be somewhere here. So the distance between this point and the center can be located. From the figure, the point lies outside, and let us show that the distance between negative 3, negative 4 and 2, 3 is greater than the radius of the circle, which is 5. So 2r is d squared. 2r quantity square is d squared, negative 4 squared, plus negative 6 squared minus 4 times negative 12. So that's why r is 5 units. Then the nearest distance is this distance here. That's the distance between negative 3, negative 4 and the center, less 5 units. So d is distance between negative 3, negative 4 and 2, 3 is by distance formula 2 minus negative 3, so 2 plus 3 squared, plus 3 minus negative 4, so 3 plus 4 squared. In decimals, that's 8.602 units. Therefore, the nearest distance is 8.602 minus 5. By the way, the distance is greater than 5, so negative 3, negative 4 lies outside the circle. The nearest distance is 8.602 minus the radius of the circle, so it is 3.602 units. For the farthest distance, it is 8.602 plus 10 plus 2r, or sorry, 8.602 plus 5. So it is 13.602 units, 13.6 to 4 significant figures. Then the length of the tangent line from the point to the circle. So this is the point, and let's draw a line tangent to the circle. The tangent and the radius are perpendicular to each other as shown. The distance between them is equal to tangent square plus radius square. So since this is 5 square, 25 plus 7 square, 49, square root of 74, square root of 74 square equals t squared plus 5 square. Solving for t, t is equal to 7 units. And the other way is this, the point of tangency here is at negative 3, 3, and the distance between 3 and negative 4 is 7. 3 minus negative 4 is 7. So that's the other way, and the shorter and the easier way. But let's just have this solution in general way. Then what is the length of the chord? 3 units from the center. So we have a chord here, that's 3 units. This is the radius is 5 units. That's L sub c. That's 5 units. This is 3 units. So this must be 4. L sub c over 2. This is half of the length of the chord. Should be 4. L sub c over 2 equals 4. So L sub c is 8 units. So that's it for this problem. Problem 11. What is the equation of the radical axis of the circles x squared plus y squared equals 36 and x squared plus y squared minus 20x plus 36 equals 0? What is the length of the common chord? How about the length of the common external tangent? For the radical axis, we substitute the value of x squared plus y squared into this equation here. So we have, for the first circle, x squared plus y squared equals 36. Center is at the origin. Radius is 6 as shown. And for this one, we're going to transform this to the standard form by completing the squares in x. So x squared minus 20x plus half of negative 20 is negative 10. Negative 10 quantity square is 100. Then plus y squared equals negative 36. Then we added 100 in the left side, also add 100 in the right side. The right side is 64. x minus 10 quantity square plus y square equals 8 square. 8 square is 64. So the center of the circle, the bigger circle, is at 10, 0 here. And the radius is 8 as shown in the figure. So this is the radical axis. We replace x squared plus y squared by 36. So 36 minus 20x plus 36 equals 0. So x equals 3.6. So that means because this is at the origin, radical axis x equals 3.6. So this radical axis is 3.6 units from the y-axis. The radius of the smaller circle is 6. This is half of the length of the latus of the chord by symmetry, and that is 6. This is 3.6. So L sub c over 2 square equals 6 square minus 3.6 square by Pythagoras theorem. So solving for L sub c is 9.6 units. Then how about the length of the common external tangent? This is the external tangent. We draw a line from the center of the smaller circle parallel to this, and so that we can analyze the length of the common external tangent. So this is the length of the common external tangent. This is 10 units, the hypotenuse of this right triangle, and this distance is radius of big circle 8 minus radius of small circle 6. So that is 2 units. So therefore, the length of the common external tangent is square root of 10 square minus 2 square. And that is equal to 9.798 units. Problem 12. Determine the equation of a parabola with focus at 4, 2 and directrix of y equals -4. So to help analyze the situation, let's locate the focus. Let's draw the directrix. So y equals -4 parallel to the x-axis. That's the directrix. The focus is at 4, 2, so it's here. And this point is also 4, -4. The vertex is the average of 4, k. Let's call that 4, k the vertex. But k is the average of 2 and -4. 2 plus -4 divided by 2 is -1. So this is the expected equation of the parabola. It is open upward. So x minus 4, the vertex is 4, h is 4, quantity square equals positive latus rectum, length of latus rectum 4p times y minus k, where k is 1/2 of 2 plus -4, and that is -1. So the expected equation therefore is x minus 4 quantity square equals 4p y plus 1, where 4p, the distance between the focus and the directrix is 2p. So 2p equals 2 minus -4. So p is 3. Substitute p is 3 here. So we have x minus 4 quantity square equals 4 times 3, which is 12 times y plus 1. Simplifying, x squared minus 8x minus 12y, then 16 minus 12 is 4 equals 0. So the equation of the parabola is x squared minus 8x minus 12y plus 4 equals 0. X squared minus 8x minus 12y plus 4 equals 0. So that's it for that parabola. Problem 13. Find the equation of the parabola with vertex at 5, -2 and focus at 5, -4. So to help analyze the situation, let's plot the vertex and the focus and anticipate the equation of the parabola, standard equation of the parabola. So this is the vertex 5, -2, focus 5, -4, which is below. So the parabola is open downward. Therefore, the expected equation is x minus 5 quantity square equals -4p, negative latus rectum, times y minus negative 2. So this is the expected equation. X minus 5 quantity square equals negative 4p quantity y minus negative 2. The distance between the vertex and the focus is p, and it is negative 2 minus negative 4. So it is equal to positive 2. Substitute into this equation, then simplify. X minus 5 quantity square equals negative 4 times 2 quantity y plus 2. So x squared minus 10x plus 25 equals negative 8y minus 16. Simplifying, the equation of the parabola open downward is x squared minus 10x plus 8y plus 41 equals 0. So that's it. Problem 14. Determine the coordinates of the focus of the parabola whose equation is x squared plus 4x plus 16y plus 4 equals 0. This is a parabola that is open downward. Let's complete the square in x. X squared plus 4x plus 4 equals negative 16y minus 4 plus 4. So that is x plus 2 quantity square equals negative 16y. 4p equals 16, so p is 4. The vertex of this parabola that is open downward is at negative 2, 0. So the focus is directly below it, so p is 4. The focus is directly below this, so the focus will have coordinates of negative 2, then 0 minus 4 is negative 3. Negative 2, negative 4. That's the vertex, negative 2, 0. The focus is negative 2, negative 4. Problem 15. For the following conic, sketch the graph and label all its important elements. So these conics are parabolas. This parabola here is open to the right, and this parabola here is open upward. So let's complete the square in y for the first conic. For the first parabola, 3 times quantity y squared plus 8 over 3y, because we factor out 3. Then 1/2 of 8 thirds is 4 thirds, and 4 thirds quantity square is 16 over 9. Then equals, transpose negative 16x to the right, so 16x. Then negative 11 to the right plus 11. And the new terms added is 3 times 16 over 9. That's 16 over 3, so we also add 16 over 3 to the right of the equation. So this is 3 times quantity 4 thirds square equals 16x plus 49 over 3. Factor out 16 from the right side of the equation. So 3 times quantity y plus 4 thirds quantity square is 16 times quantity x plus 49 over 48, where 48 is 3 times 16. So divide everything by 3. Y plus 4 thirds quantity square is 16 over 3. Quantity x plus 49 over 48. So this is a parabola that is open to the right. The vertex is at negative 49 over 48, negative 4 thirds. The distance between the vertex and the focus is 1/4 of 16 over 3, so that's 4 thirds. So let's have the partial plotting first. This is the vertex, which is at negative 49 over 48, negative 4 thirds. So the focus is equal to negative 49 over 48 plus 4 thirds, negative 4 thirds. So negative 49 over 48 plus 4 thirds. 4 thirds is 1/4 of 16 over 3. So it is 5 over 16, negative 4 thirds. The equation of the directrix, which is here, vertical line, is x equals negative 49 over 48 minus 1/4 of the latus rectum minus 4 thirds. Negative 49 over 48 minus 4 thirds is x equals negative 113 over 48. And this is the conic 3y squared, which is a parabola 3y squared minus 16x plus 8y minus 11 equals 0. So 15b, let's complete the square in x. 2 quantity x squared plus 9 halves x. Half of 9 halves is 9 over 4, and 9 over 4 quantity square is 81 over 16. Then equals transpose negative 11y to the right and positive 4 to the right, so minus 4. And we added 2 times 81 over 16, that's 81 over 8. So that's why we also had add 81 over 8 in the right side of the equation. So this is 2 times quantity x plus 9 over 4 square equals 11y plus 49 over 48. Factor out 11. So 2 times quantity x plus 9 over 4 square equals 11 times y plus 49 over 88. So this is the parabola. Divide everything by 2 first. So x plus 9 over 4 square equals 11 halves. Quantity y plus 49 over 88. So this is a parabola that is open upward. The length of the latus rectum is 11 over 2. So half or 1/4 of 11 over 2 is 11 over 8. P is 11 over 8. The vertex, this is a parabola open upward. The vertex is at negative 9 over 4, comma, negative 49 over 88. Then let's have the graph 11 over 2, the length of the latus rectum. So open upward. This is the vertex at negative 9 over 4, comma, negative 49 over 88. The focus is somewhere here, and it is negative 9 over 4, comma, negative 49 over 88 plus 11 over 8. So that's negative 9 over 4, comma, 9 over 11. The directrix is below. It is y equals negative 49 over 88 minus 11 over 8, and that is y equals negative 85 over 44. And this is the graph of the curve 2x squared plus 9x minus 11y, 2x squared minus 11y plus 9x plus 4 equals 0. Problem 16, an arc in the form of a parabolic curve with the vertical axis is 60 meters across the bottom. The highest point is 16 meters above the horizontal base. What is the length of a beam to be placed horizontally across the arc 3 meters below the top? So let's apply squared property of parabola here. This is 60 meters. The height is 16 meters. And we have the length of beam. We do not know the length yet, L, and distance 3 meters from the top. So by squared property of parabola, L squared as to 3 equals 60 squared as to 16. L squared as to 3 equals 60 squared as to 16. Using your calculator, L is 60 square root of 3 over 16, and that is 25.98 meters. Problem 17. Determine all important elements of the curve x squared plus 6x plus 12y minus 3 equals 0, which is a parabola that is open downward. What is the area bounded by the curve and its latus rectum? Sketch the graph. So let's transform this equation, general equation of parabola, to its standard form by completing the squares in x. So x squared plus 6x plus 9 is equal to negative 12y plus 3 plus 9. So quantity x plus 3 square equals negative 12 quantity y minus 1 after we factor out negative 12. So this parabola is open downward with vertex at negative 3, 1. Length of latus rectum is 12. So let's have the graph. Vertex is at negative 3, 1. And the directrix is y equals 1 plus 1/3 of 1/4 of 12 is 3. 1 plus 3 is 4. So the equation of the directrix is y equals 4. The focus, by the way, is negative 3, comma 1 minus 3, negative 2. So, negative 3, comma 1, the directrix is y equals 4. 4 is 1 plus 1/4 of 12, which is 3. So, y is 4. The focus is negative 3, comma 1 minus going down. So, 1 minus 3 is negative 2. The equation of the axis is x plus 3 equals 0, or x equals 3. And the length of the latus rectum, this is the latus rectum, 2p is 6. So negative 3 minus 6. So this is negative 9, comma negative 2. And this one is negative 3 plus 6, 3, comma negative 2, r. And the area is LR square over 6, where LR is equal to 12. So 12 square over 6 is equal to 24 square units. Problem 18, a point moves so that its distance from 3, comma negative 1 is equal to its distance from the y-axis. Find the equation of the curve. So this is expected to be a parabola because we have a fixed point and a fixed line. The y-axis is the fixed line. That's the directrix. So this is the fixed point, and this is the point on the directrix. So the vertex should be somewhere here in between F and D, and it is open to the right. The expected equation therefore is y minus k quantity square equals 4p quantity x minus h. So we have here the point x comma y. Its distance from the y-axis is just x. Distance d is x. Distance from focus is distance f. So distance d equals d sub f. D sub d square equals d sub f square. D sub d is x square. And d sub f square is quantity x minus 3 square plus y minus negative 1 quantity square. Y minus negative 1 is y plus 1 square. So x square equals x square minus 6x plus 9 plus y square plus 2y plus 1. Cancel out x squared. Simplifying, y square minus 6x plus 2y plus 10 equals 0. So that's the equation of the parabola. Y square minus 6x plus 2y plus 10 equals 0. Problem 19. A parabola passes through 3, 4. The vertex is at the origin and the focus is on the x-axis. Find the length of its latus rectum. The focus is on the x-axis. It passes through 3, 4, which is a point in the first quadrant, so the parabola is open to the right. The expected equation is y square equals latus rectum times x. We substitute the value of x and y. So 4 square equals latus rectum times 3. Latus rectum is 16 over 3. Therefore, the equation of the parabola is y square equals 16 over 3 times x. Problem 20. The axial cross-section of a headlight reflector is a parabola with the bulb's center as the focus. Find the depth of the headlight in centimeters, knowing that the bulb center is 2 cm from the vertex. So take note that the distance between the vertex and the focus is 1/4 of the length of the latus rectum. The distance from the focus to one end of the latus rectum is 2 times p. So 2 times 2 for cm. And the radius of the base of the headlight reflector is 10. So drawing the headlight reflector, we have the focus, which is the bulb center, 2, 0. The vertex is 0, 0. So that means this is 2 cm between vertex and focus, distance between vertex and focus. Focus to one end of latus rectum is 4, where 4 is 2 times 2. And the radius of the bulb is at the base is 10. We are looking for this depth of the headlight reflector. This is 10. Then by squared property of parabola, 10 has to D as to 10 square equals 2 as to 4 square. So D as to 10 square equals 2 as to 4 square. So D is 12.5 centimeters. So that's it for this video.